And you should be good.
Awesome. All right, hello, I am David Kolb. I work with Paul Daigle over at Mannheim. We're on sibling teams. And he talked me into giving you this Elixir talk last night. So, good luck. So I've worked for Mannheim. I actually live in Fort Lauderdale and I fly up here almost 50% of the time to work. So. My teams, Paul Daigle's team had already written and deployed some Elixir and they were telling us how great and wonderful it was, and my team was like, oh hey, well we need to write this little app that picks up blobs of JSON off SQS and throws them against AWS Simple Email Service and sends some emails. Well, we thought it would be so simple. Yeah, no, not so much. So the first thing we decided was we were going to do Elastic Beanstalk worker environment, which is basically you tell Elastic Beanstalk, here's the SQS queue, and Elastic Beanstalk runs a little daemon on your EC2 instance that pulls messages off of them and throws them against your application. Elastic Beanstalk does not actually support Elixir directly, so we decided to put it in a Docker container since they have a Docker platform. And inside the Elixir application, we were using, we actually dipped down into Erlang and used ETS tables to store messages. One of the major reasons that we were having to write this as a microservice is that our main application is an eventing application, and this was to send email alerts that people's HTTP callbacks were not receiving events. And when we did this at first, our database is Cassandra, which is eventually consistent. Eventually being the key word, and we ended up sending people like 30 emails in 10 seconds. So, apparently people don't like that. Yeah, so what we decided to do was use a Elixir microservice and queue the messages up and basically deduplicate them over a 5-minute window. Email's slow anyway, no one really notices 5 minutes. So the interesting thing about Elixir and by extension Erlang is all languages try to solve a problem, and they usually try to solve that problem by declaring something the enemy, and in Elixir state is your enemy. If you ever want to store something and save it for later for maybe another HTTP request, you actually have to create what's called a gen server, which is an entirely separate process that stores your state, and you basically call that process to say, hey, what's my state? And it hands you back whatever variable you decide to store in that particular process. And my laptop apparently thinks it's going to turn off. The other thing we noticed, which I'll get to when I get to a later slide, is that there's a lot, Elixir's really young, there's a lot of stuff that isn't already there that you would just expect to be there in other languages. For example, an AWS SDK. So stuff that was awesome was ETS tables. There's also a library called Bypass. An analog to Bypass would probably be different tests in different Java libraries, really, that basically open up a port on localhost and you tell it, hey, when you get a web request, return this. Ruby does not need that because Ruby has WebMock. WebMock is awesome. I wish Elixir had WebMock. Stuff that was not awesome at all. So because the AWS Elixir, AWS Erlang, and AWS CodeGen projects do not currently support anything that uses the query protocol. And so they only support stuff that uses JSON RPC and just straight JSON posts. The other thing is that so because those do not support that protocol, we ended up having to make our own calls. To make our own calls, we had to do our own request citing. Fortunately, there's actually a library, a dependency you can pull in called AWS Auth that does the signing for you. The problem is that AWS Auth, if you don't give it various parts of the AWS APIs that it expects when signing, for instance, the SHA-256 summon stuff, it'll generate that on its own, but it doesn't give that back to you. So you have to very carefully craft your request in code before you hand it to AWS Auth to sign the request. If you've ever dealt with digital signing in XML documents or any of that wonderful sort of thing. This is pretty much it because Amazon likes to build what it calls a canonical API request and then sign it. And if you've ever dealt with XML digital signature, you should have like PTSD from the word canonical. There's another very specific problem with simple email service, and it's actually kind of widespread around the AWS API, is that when you're using temporary credentials provided by the EC2 metadata instance, which is basically just pulling credentials from your IAM profile, what an EC2 instance is allowed to do, it gives you a security token. Some parts of the API want that security token to be part of the signed of request. Other parts of the API want you to add the signed request as a header after you sign your request. I don't work at AWS, I can't tell you why. The other fun thing is that these AWS libraries for Elixir and Erlang do not support temporary credentials. We had to roll our own gen server to retrieve and cache temporary credentials. And then we actually had to figure out how to set a timer on a process and do some date math, because when you retrieve your temporary credentials, you're given an expiration, but there's actually no way to say to Erlang, hey, call this function at this exact point in time. Instead, you have to say, hey, call this function in the future. And I tell everyone the worst thing to ever do in programming is date math. So, also, none of the syslog libraries will talk to remote syslog links. We use, we're pretty heavy on Docker in Mannheim. And so we often set up a Docker container that is nothing but our syslog running with an open UDP port that forwards all of those log entries to Loggly. So that doesn't work. So what we actually ended up doing was just logging to standard out and having the actual Docker daemon use the syslog logging process and modifying the EC2 instances to forward their syslog to Loggly. So the main meat is, because I am actually only a part-time dev on the team, I am also their AWS guru, and I often get things thrown at me at light speed and told to make them magically appear in Amazon Web Services within 2 days. So obviously we had chosen Docker. We used EXRM, which is Elixir Release Management. It compiles and writes fancy scripts for starting up and stopping your application. SIGTERM is hard. So when you stop a Docker container, it sends a SIGTERM, but it only sends a SIGTERM to the process inside the container that has a PID of 1. And when that happens, the problem is that when you're running the command to start your application, and we'll cover that in a minute when I go to the demo, is that it's a bash script. And bash does not like handing SIGTERM to the processes it's running when you tell it to terminate. So we actually had to wrap everything in a Perl script that runs, because Perl handles SIGTERM better than bash. I don't know why. Yes, and we tried trapping SIGTERM before you ask. But it's like the bash script was running another bash script, and then the SIGTERM was supposed to call basically the equivalent of service stop, and Docker and bash were having none of that ever. So we're going to pop over to a Docker demo.
Your Unix beard is growing 2 feet longer.
My what?
Your Unix beard is growing 2 feet longer.
I do have a very large Linux beard.
There's AWS and there's everything else.
Well, so AWS does require some stuff, but I am also a Z shell expert. If you look at, that's stuff that I use to SSH into an instance ID without having to know its IP address that I ended up writing. So, yeah. So this is just your basic Elixir app. I'm actually using Plug, which the Ruby equivalent would be Rack, which you just got a wonderful talk on. If you're looking for something more Rails-like in Elixir, I advise starting with Phoenix. You have a mix EXS, which is sort of a combination of a rake file and a gem file, all combined into one. Let me open tmux so I can scroll easier. So it has you define your application. Dependencies, basically hex modules, which would be the equivalent to gems, are actually applications, and they have initialization functions. And in order to call those initialization functions, you have to add them to this array of applications. And you describe your product and your dependencies. This is the typing ahead of myself. This is the Docker file. So Docker files just describe basically how to build a Docker container. Docker container is a very lightweight virtual machine running on LXC, LHC, some magic Linux stuff. See, my Unix beard is growing shorter now. So you start with the Elixir Slim, which is just a Docker container that has Elixir and supporting libraries installed. Mix, it would be the equivalent of rake. This installs the dependency retrieval, and this installs rebar, which is a compiler. We copy in the files that we use for our dependencies. We get and compile our dependencies, and then we copy in our application sources. And so we ran into an interesting problem where we were trying to run the build locally. We use Circle CI on our team, and the Ubuntu container that it builds on when it compiles apparently links the libraries in some weird way. This is a compiled language that we're using. So it links them in some weird way and it would not run in the container. So we actually compile the application inside the container. And then once we have a release, we copy in our run script and that runs. And run.perl is just basically, it runs this command. This is the bash script that is basically the equivalent of starting your application as a service. The foreground just makes it latch on to the sysout and start keep running so that the Docker container doesn't terminate. Sigterm captures when you run Docker stop and stops and then ends itself. And that's pretty much it. And excuse me. And then this just basically is running the build. And then you can whoops, need to map the port.
You misspelled hello.
Did I?
Yep, just spelled it.
Oh.
Hello.
Yes. And here is a plug. Oops, I think it's, sorry. That's actually the not found. And I did that again. Go me. So this is just localhost 4001/hello, hello world. And if you wanted to see the code around that, that's just basically that. And as you can see, it looks a heck of a lot like Sinatra, really. So, that's Elixir and how to get it to work in Docker, and many warnings about trying to talk to AWS with Elixir.
I was just going to say, I'm a huge Elixir fan.
Yeah.
If you are using Phoenix, which is very Rails-like, you can get it running on Heroku in like 5 minutes. And so I was able to publish to Heroku just like that. I mean,
Yes, but
I
you
know
know.
you can use Heroku in all cases, but if you're like looking to toy around with something, I mean,
The thing, and I'm done at the end of the thing, it's run on Elixir and Heroku.
Yeah.
Like,
band is for?
Heroku is great for demos, it's great for getting started, and then when you start scaling, Heroku shows up with the bill that you can't pay.
It's true, but then it's like, I mean, you saw trying to get stuff running. I pay a lot of money to Heroku to avoid messing with AWS sign-in.
To be perfectly honest, almost everything can run in Docker, and AWS really has upped its Docker kind of offerings, especially with Elastic Container Service. It is still harder than Heroku.
Yeah.
But once you have your app out there and you want to start scaling it and you want to save money scaling it, you can with Amazon Web Services. It gets very reusable and very fast the first time you get a microservice out there. The next microservices really do take me only 2 or 3 days. The main problems is I have to go back to the devs and be like, I had to rewrite half your logging code because you can't log like that, okay? But yeah, no, definitely Heroku. Anything that supports just doing a git push to deploy your Elixir code is probably a great way to get started. Amazon does not like it. Amazon is the Walmart of cloud services.
Yeah.
Saw a hand back up? Yeah.
Why did you use Elixir for this particular microservice?
So it was either that or Camel, to be quite honest. Apache Camel, it runs its Java framework. Not sure if you're familiar with it, but it does a lot of enterprise integration patterns, and it could also handle the deduplication. This was actually sufficiently small enough, and we had been looking at Elixir as a possible kind of language we want to start using more. So this seemed a really good kind of stress test for Elixir. And if you look into ETS tables, which is actually coming from Erlang, Elixir kind of is syntax sugar on top of Erlang, really. Kind of. Well, at a logical level. So the thing is that you can run Erlang from your Elixir app, and inside Erlang is ETS tables, and they're very fast in-memory caches that you can do a lot of cool things with, like basically make sure they're unique. You can also access ETS tables from other nodes. So when we scale this, the ETS table will live on one EC2 instance, and all the EC2 instances will be able to add to it and process from it. So it's I can't remember the name of it, something we used in Java that would basically let you have a map and you could automatically talk between like all of your, it would automatically discover different servers and you could share memory between them. So it's like shared memory. And I think that's it. Anything else?
This video has been sponsored by Rieta Incorporated. Learn more today at RIE.